This is geometry, section 7.3, page 511. And we're talking about similar triangles again. If you remember that similar triangles are, or similar figures are, two things have to happen. Their angles have to be congruent and their sides have to be in proportion. So in order to prove two polygons, figures, similar, we have to prove that all the angles of one are congruent to all the angles of the other and their sides are proportionate. However, in triangles we can take some shortcuts, and the first shortcut that we have is called the AA Similarity, and this happens to be a theorem or a postulate, and it says if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar, okay? And that cuts off a lot of time because we can pretty much cut down to having to prove, we can prove all the angles are congruent, but that the sides are in proportion. That helps us. It only works with triangles, unfortunately, so that is one good thing about triangles, but it doesn't help us with other polygons. Now, if you look at this situation, we can have a situation like this where we determine whether the triangles are similar. If so, write a similarity statement, okay? I apologize for my triangles. They are not great triangles, but here we have two triangles. In this triangle, angle J is 48 degrees, L is 57 degrees, K is unknown, M is 57 degrees, P is 75 degrees, and Q is unknown. So what we want to know is, can we prove this by two triangles congruent? And if we can, what's the similarity statement? Well, we have to have the idea that these are added together, add up to 180 degrees. So we can find the third angles, and we need to do that. So if we take 48 and we add it to 57, we get 105, and then take 180 that. This happens to be a 75-degree angle. Okay, well that matches this, doesn't it? And then this matches this. So these two triangles are congruent, or excuse me, are similar. Now the important thing is yes, they are similar, but then we have to write a similarity statement. So we begin with, I'm going to begin with this triangle. I'm going to say triangle, and I'm just going to go JKL is similar to triangle. Now I have to match J. J is 48 degrees. That must be what Q is because those values add up to 180 also. So we start with Q. And then K, we look at K is 75, that matches P, and then we have M. So our similarity statement is triangle JKL is similar to triangle QPM. Okay? Now the same thing goes here. We have two triangles, this triangle here and this triangle here. We want to know whether they're similar. This line is parallel to this line. We have marked that so. And so we want to know. We do know that this angle is congruent to that angle because vertical angles are congruent. And we also know that this angle is congruent to this angle by alternate interior angles. It's also that this angle is congruent to that angle. So we have at least two angles congruent. Therefore, these two triangles are similar. Yes. And we can write it as, and just choose the three letters. So I'm going to start with RST is similar to triangle. And now I match R. R matches W. S matches S. And then T matches, whoops, this is X over here. That's an X. So it's RSX. Sorry, I can't read my own writing. So then this is WST. Okay? Now, an example of maybe we wouldn't, where they weren't similar, is maybe something like this, and this would be example on page 513, letter C. We have something like this, a triangle like this, and I'm going to have trouble writing the angles in here, but this is 32 degrees, 32 degrees, and this one is 29 degrees. You can see those somewhat. This one is 121 degrees, and this one is 32 degrees. Okay. Now, if you add up these two, you can get 32 plus 29, so that equals 61. And taking that from 180, this is 119 degrees. Okay, that is not the same as that. So no, these are not similar. Okay, so there's a case where they're not similar. All right. So if we use similar triangles, triangles are, first of all, triangles are similar to themselves. Second of all, if one triangle is similar to another triangle symmetrically, then the second triangle is similar to the first. And the transitive property also works with similarity. If one triangle is, if triangle A is congruent to triangle B and B is congruent or similar to, excuse me, if A is similar to B and B is similar to C, then A is similar to C. So it transfers over. Now we're going to look at an example of trying to find measures of triangles using the concept of similarity. So if you look on page 514, this is example 3. So we'll go ahead and put 3. I'm going to draw the figure like this and try to make it big enough that I can put the angles in, and it looks okay. And they tell us that these two are parallel. All right, and this is A, this is B, and this is C. This is E, and this is D. Okay. We also know that this is X, this is Y, this is 3, and this is 3.5. The only that we do know that this is 3, and the whole thing here is 5. Okay. So the question asks, find BE and find AD. So we're going to find BE and AD. Okay. So let's take a look at this. Basically, we have a little triangle here, and then the bigger triangle here. Okay, and we can start by saying 3 is to 5, and it's the whole thing. So 3 is to 5, because those two sides are given. This 3 here and the whole thing. Now that match up, then that can tell us that once we do the little triangle, we go back to the little triangle. So we're going to do x over 3.5. That's its matching. Okay, and so if we cross multiply, we have we have 3 times 3.5, and that equals 5x. So 3 times 3.5 is 10.5, and that equals 5x divided by 5, and we get x equals 2.1. If you look at that. Now that's BE. Now, to find the other one is a little harder. We still use the 3 and the 5 because those are corresponding sides. But then we come back here, if we find y, that equals y over, and as we look here, we see that the whole side, we need the whole side. We don't have the whole side. So what we do is we put y plus 3. That is the whole side, and we have a quantity. So when we multiply, we have 3 times y plus 3 equals 5y. So we're going to have y's on both sides. Using the distributive property, we have 3y plus 9 equals 5y. And then we subtract 3y. I'm going to subtract 3y from both sides. And I get 9 equals 2y. So y equals 9 halves. And that would finish over 4 1/2. Okay? So that would give us that value. So remember, we got to go the one piece of the side to the whole, so it's the same here. That's why we have the y plus 1. Okay? All right. So looking at our exercises, we start with number 9, and it says determine whether the triangles are similar. If so, write a similarity statement. Make sure you're paying attention to the triangles that they tell you on 9, because there's more than one triangle. On 10, 11, there's 2 triangles. So we're going to jump to number 21. I want to do 21. It is in your assignment. It looks like this, and I'll try to draw it as quickly as I can. It's got to be like that. This is 10. H. This drops down like this. And this whole angle is congruent to this whole angle. And then this is marked. And we have 2x plus 4 and 2x minus 2. This is 7, and this is G, and this is J. And this point here is D. Okay. So I think I have everything, and it says identify similar triangles, then find each measure. That's the direction. So we're going to have to find x, and then find the sides, because this is a measure we're looking for, and this is a measure we're looking for. The problem is which triangles are congruent. Well, you can see that this angle matches that angle. We're talking about this triangle here and the whole triangle, okay? So when we get our 2 triangles and they're similar, let's write it down so we kind of have an idea what's going on. G matches itself. So each one, G matches itself. How do I know that? It has 2 marks at G, so it matches itself. Okay, this angle H matches angle D, okay? And then this point up here, H on this one, or excuse me, H on this one, J right here matches D, this H up here. So let me go through that again, because it kind of got twisted around there. GHJ matches GDH. Okay, so it's kind of twisted. What that does is that helps us write a similarity statement so we can get it. The 7, GH, matches HJ. Whoops. GH, sorry, matches HJ. Okay? Is that right? I'm sorry, that is not correct. That's why you mark it. 7 of this triangle, the little triangle, 7 over 2x minus 2, because that matches that, because HG matches GD, okay, or HG matches GD, and that equals 10 of the big triangle matches 2x plus 4 on the little triangle, okay? HJ matches DH. HJ matches DH. So I have my proportion there. So I cross multiply, and I have, once I get this, I have 7 times 2x plus 4 equals 10 times 2x minus 2. And if I distribute through, it's 14x plus 28 equals 20x minus 20. Okay? I'm going to change this plus negative. I'm going to subtract 14x from both sides. And I get 28 equals 6x plus negative 20. And then I'm going to subtract a negative 20 from both sides, which is the same as adding 20. And I get 6x equals 48. So x equals 8. Okay? So that's just the value of x. The next question says find the unknown value. So I go back up into it and I say 2x plus 4 is really 2 times 8 plus 4, which is 16 plus 4, which is 20. And this gives me HD. This is the length of HD. And then I have 2x minus 2, which is 2 times 8 minus 2, which is 16 minus 2, which is 14, and that is GD. Okay, so those two values I now know on that. Each one you have to find x and then plug it back in. All right, that's number 21. Just to finish this out, your assignment is page 516, numbers 9 through 14, comma 16 through 24. You do have a couple story problems there. I can do one for you. We can do number 23 real quick. If we get a minute here, let's take a look at 23. You can work it with me. It says, when Alonzo, who is 5 feet 11 inches tall, stands next to a basketball goal, his shadow is 2 feet long, and the basketball goal's shadow is 4 feet 4 inches long. About how tall is the basketball goal? Okay, well, we have the basket, the sun, okay. This is the goal right here, the basketball goal. Okay, we'll put a little hoop up there. And then Alonzo's right here. Okay, he looks a little tall there. Okay, right here. The sun is bearing down. Okay. All right. I believe we have 2 triangles here. And we can switch sides too. I mean, but if you want to break it up into 2 triangles here, this is Alonzo, and we can do it like this. But the triangles are going to be similar. And this is Alonzo here, and the sun bearing down on the basket. Alonzo is 5 feet 11 inches, and he casts a shadow of 2 feet. Okay, and the goal casts a shadow of 4 feet 4 inches, and we want to find, it says, how tall is the basketball goal? Okay, that's probably a better way to draw that instead of putting them together, because we can clearly see these now. And one thing you have to do is you have to convert the inches to feet. So let's go ahead and do our similarity. We have a 2-foot shadow to a 4 foot 4 inch shadow, and then we have a 5'11" Alonzo to the basket, and it becomes X. One thing I want to point out here is that we need to change these. So we do get 2x equals, and the way we change is we get 4 plus 4 divided by 12, or that would be 1/3, 1 divided by 3 times 5 foot and 11 divided by 12. That does not come out so evenly. So I'm going to use a different calculator on that, I think. Yep. So looking at that, we have, let me get that value here, this one here, 4 plus 1 divided by 3 times 5 plus 11 divided by 12. Trying to do this so we don't have to. Okay, so that is 2x equals 25.638 with a line above the 8, and if we divide that by 2, we get x equals 12.8 feet. So the basket is 12.8 feet, not regulation, but that's how long we do that. I do want to point out that you have to be careful when you're doing a problem like this, because if you round it too soon, you don't get the correct answer. So keep that in mind. Okay, that assignment of page 516, 9 through 14, 16 through 24, you'll be working on that today. And we'll continue on then.